Hello everyone, welcome back to another video. So today we are going to discuss editorial for weekly contest 433. I was able to solve first three problems. I also had an idea how to solve fourth one, but I couldn't implement it. My current rank is 811. I think I found third problem way more easier than second. I got some unnecessary TLEs on second. We'll get back to that later. But let's start with the first problem. As usual, the first problem is always brute force, at least on Leetcode. So what we are given is we are given an array of nums size n, and we need for each index I we define a subarray as nums of start to end index as I, where start is max of 0 comma I minus nums of I. Now we need to find total sum of all the elements from the subarray defined in each index. So what we have, let's see the example first. So first is nums as 2, 3, 1. Now for nums of 0, that means I equal to 0. End index is 0 and its start index is max of 0 comma 0 minus 2. So max of 0 comma minus 2. So start index becomes 0. So 0 to 0 subarray. Similarly for second and third, these are the examples. For what we need to do is for every I in 0 to n minus 1, we uh, we fix a starting index which is max of 0 comma I minus a of I. And once we fix the start index, we iterate from start to I and add that to our sum. So this is iterating over I, fixing the starting index of that subarray, then iterating over that subarray and finding the sum. That is this. That is the solution of this question. So I have declared an answer variable, and I am iterating over I, finding the starting index with the formula, and then iterating over that subarray and taking its value to my sum answer variable. Pretty simple brute force solution. Now let's move to second question. Now second question is way more difficult than, not way more, but definitely more difficult than third one. But let's try to solve the second one first. So what we are given is an integer array nums and a positive integer k. Now what we need to do is we need to return sum of maximum and minimum elements of all the subsequences of nums with at most k elements. So for each subsequence of length less than equal to k, whatever maximum minimum element in that array is, we have to add that to our sum variable and finally return that sum variable. So we need to find sum of maximum and minimum elements of all the subsequence of num which has length at most k. So in this case 1, 2, 3, and where k is equal to 2, the subsequences of length less than equal to k are this subsequence: single elements, then two elements, and the minimum maximum value is represented in second and third column, and then taking the sum of all the minimum max, and finally final total would be 24. So answer is 24 here. Similarly for this, answer is 22. K is 1, that means only one element in subsequence is allowed. So 5 twice, one as max, one as min. Similarly 0 twice and 6 twice. So 10 plus 12, 22 is the answer. Similarly here answer is 12. Now, in these types of questions where finding subsequences is not optimal because here n is n raised to power 5. So if you have to find all the subsequences, it would be of order 2 raised to power n. So we cannot do that. What we can do is for each element we can find its contribution in overall sum or in our answer. For example, this one is contributing thrice in minimum and once in maximum. Similarly, this 2 is contributing twice in minimum and twice in maximum. And 3 is contributing once in minimum and thrice in maximum. So this type of contribution. How can we do that? So for x to be minimum, let's say x to be minimum. So all the elements in the subsequence should be greater than equal to x. So let's say there are mx elements which are greater than x. So out of these mx elements, if we try to create a subsequence of length at most k, and x is already there in that subsequence. So out of mx, we basically need to find uh, out of mx, we basically need to put all other elements in that subsequence. Now for length k equal to 1, it is already filled with x. For k equal to 2, we have one option. For we need to fill one space. For k equal to 3, we need to fill two spaces. And for something like if we have to make subsequence of length k itself, we need to fill k minus 1 spaces. Now for uh, filling 0 spaces, what is the possible way? No possible way, only one possible way, that is the array itself. Now to fill two uh, one space in out of mx elements, what is the possible, uh, so we have to fill one space, so mxc1, basic combinatorics, mxc2 up to mxc k minus 1. So these are the ways to fill all those subsequence of length 1 to k. Now these are the possible combinations, and contribution of that element is x. So this is something we need to add in our answer variable. Similarly, this is the case for finding x x when x is added as a minimum element. Now if x is to be added as max element, then all the elements which are less than equal to x needs to be considered, and then our equation would become like mnc1 mnc2 up to mnc k minus 1. So for each element, what we need to find is we need to find its less than equal to count, it's greater than equal to count, and then use this combinatorics PNC formula to find its contribution. And once we find contribution, we just add it to our answer by multiplying it with x. So x in each way we are adding x. So total sum would increase by this weights into x. This is the solution. Now I will explain you the solution first, and then uh, then I will explain how I did this NCK and all that stuff. So first of all, what I have done is I have sorted the array to find lesser and greater elements easily. Now, for I equal to 0, I less than n, I plus plus. These are the elements which are greater than equal to x, and these are the elements which are less than equal to x. Now there is additional minus 1 in each of them because we need to exclude the current element. Now I have declared a d variable to find its contribution. So then I'm iterating from 0 to minimum of k minus 1 comma mn, and basically finding nck of mn and j. So this mnc1 mnc2 up to mnc k minus 1 or mn itself when k is greater than mn. When mn it's so if mn is greater than k minus 1, then go up till k minus 1 only, and if it is less, then go to till mn only. So this is for minimum. Similarly, I'm finding contribution for mx, and finally multiplying it with a of I and taking and adding that answer to d. Now also this mod is used whenever there is required because we need to the answer is too big, so we need to find one in answer to be modulo 1e9 plus 7. So this is the main logic. Now how this nck is performed. Also this is the constraint, so 10 raised to power 5 into k, so 10 raised to power 7, as it is very close to our limit of 1 second. So for better understanding, so 1e6 passes under 1 second, so 10 raised to power 6 iterations it will easily pass. Now if you try to go closer to like 1e8, so 1e7 will barely pass the limit if the all other operations which you are using are highly optimized. So here there can be some uh, expensive functions. Expensive means of O of log n or O of n type of multiple type of functions outer of this loop, out of this loop. So something like multiplying this x times because of this expensive functions. So 5e6 will pass in 1 second. But here if you use more expensive uh, functions, such as here we are using multiple mods, so whatever code you are writing it should be highly optimized at, because if it is not enough optimized it will give TLE. That's why I got 3 wrong TLEs on this question. So I I did some optimization based on this TLEs, and finally it got accepted. So what optimizations I did? First of all, what I was doing is for NCK, I was calling a function NCK, which was basically finding inverse modulo. Now, in what what NCK is? So NCK is n factorial by k factorial into n minus k factorial. Now to find this with modulo, what we need to find its mod. So for that, what you do is take n factorial's mod, then take k factorial's inverse mod, and also take n minus k factorial's inverse mod. Now inverse mod is of log n complexity, so calling this n times was giving me n log n complexity, and it was giving me TLE. So another way of doing it is based on this formula, that is NCR plus NCR minus 1 is equal to n plus 1 CR. So based on this formula, you can create a pre-computational DP. So you don't need to call this inversion function. So you will basically compute NCR for all the values of n from 1 to 25 and r from 100 to 1. So how do you pre-compute it? Using this DP type of structure. So first of all, NCK of 0 0 is 1, and NCK of I comma 0, whatever is I, it would be always 1, but 0 of I would be 0 always. So this is like filling first row and first column. Then iterating over 1 to n, 1 to minimum of 100 comma I, and then we are using this formula, ncr of I, uh, nck of ij is equal to nck of I minus 1 j plus nck of I minus 1 j minus 1. So this formula, and finally taking its mod. Now whenever I have required nck of any two elements, I am calling this matrix. So here complexity becomes n into k, which is 10 raised to power 7, but previously if you are using inverse modulo, it would come out to be n into k into log n. So 10 raised to power 7 into 16. So it was it was going about 10 raised to power 8. So that's why it was giving me TLE. So this is the second question. Now let's solve third. Third is pretty easy than this second one, because I never use this type of pre-computation, because generally in combinatorics problems the logic has less complexity and pre-computation has high complexity. So means high complexity is allowed in computation, logic has, so more of one type of solutions are there in combinatorics. So whatever operations you do of factorial and nck, they are allowed. So inverse modulo, they are allowed. So my first intuition was to use inverse, and then I moved to this type of pre-computation. So I found this more difficult than this one, third one. Third I barely solved in 10-15 minutes. It was a lot easy to understand. So in this case, we are given an even integer and representing an n cross 3 vector, and in each vector there is cost of painting house I with color j plus 1. Now this statement is little bit confusing, I would say, and we are given this condition that the houses will look beautiful if their no adjacent houses are painted the same color, and houses at equidistant rows, equidistant ends from row, are not painted. So if n is equal to 6, houses at position 0, 5, 1, 4, 2, 3 are at equidistant from, are considered equidistant, so their color should not be same. So let's say there are n houses, 0, 1, 2, 3, then dot dot dot. There is n minus 1, n minus 2, n minus 3. So what conditions we have is 0 should not be equal to 1, and 0 should also not be equal to n minus 1. Similarly, this one should not be equal to its adjacent, that is 2, and it should not also be equal to n minus 2. And we have to basically find minimum cost to paint their houses. Now, it is not mentioned here, but main observation over here is we only have three colors of, let's call them color 1, color 2, color 3. So let's start with first observation, that if we have to paint first and last house, what are possible combinations? So first combination is give it color 1, first house as color 1, last house as color 2. Similarly 2 1, 1 3, 3 1, 2 3, and 3 2. So these are the possible combinations. So now each pair has 6 combinations. So 0 and minus 1 has 6 combinations, 1 and minus 2 has 6 combinations, 2 and minus 3 has 6 combinations. Now out of these 6 combinations, there are some incompatible combinations. What are those? Where let's say 0 comma n minus 1 paints 1 comma 2. Now 1 comma n minus 2 paints a combination 1 comma 3. Now this is not compatible because 0th house and first house had same color. So this is not possible. So what we need to do is, for all n minus 2 pairs, we need to check all six combinations and and based on it we need to find minimum cost. Now this becomes a pretty standard DP problem. You might have heard of this problem, kind of. So if you are at ith position from I minus 1 of, there are 6 combinations, you need to pick you need to form 6 answers for this ith index. Now 6 answers are based on if we paint current index with one of the combination. So 1 3 2 3, some all this. Now if you paint ith combination as 1 2, its transition can be I minus 1 to all the other combinations uh, which are not conflicting with the R condition. So if we paint ith index pair with 1 comma 2 color, now I cannot paint 1 comma 3 1 comma 2. It will uh, the first house will conflict, so I can either paint it with 2, and second one I can paint it with 1, or paint it with 3. And third option is to paint the first one with 3 and second one with 1. So for ith index, if I paint this combination, its transition would look like I minus 1 2 comma 1, or I minus 1 2 comma 3, or I minus 1 3 comma 1. So this is the kind of solution. So first of all, I have declared a DP of size n plus 1 and 6 combinations, as there are 6 combinations. We don't even need n plus 1, we just need n by 2, but I just did it uh, for safety. Then I have declared an options variable. For my understanding, it is not used here. But what options we have? 1 2 2 1 1 3 3 1 2 3 and 3 2. Now, first index, if there were only two houses, first and last, what 6 combinations we have? We paint one first house with one, second house with two, second first house with two, second house with one. So all these combinations we tried and stored it according to its index. So zeroth index stores when last house is painted with this uh, combination. So first index stores 2 1, second index stores 1 3. Now I am iterating from I to n by 2. Now if we have to finish ith house with this combination 1 2, so we will take ith index 0 cost its counterpart, that is n minus I minus 1 first 1. So cost for second, cost for painting it with painting the house with second color is at index 1. Then I'm taking its transition to its previous house. Now its previous house can be either this combination, either this combination, or either this combination. Now it is not allowed to make itself because the adjacent house will have same color. Now it is not allowed with second option also, because if you are painting current house with 1 2 and its previous house is painted with 1 3, so 1 1 there is conflict as adjacent have same color. Similarly, uh, 2 cannot, 2 is not painted, and 5 is also not, cannot be with fifth option, it cannot also not be painted because we have painted the current house with 1 2. Now its previous pair was painted 3 2. So houses from the right side will have adjacent color as same, which is 2. So that is also not allowed. So these type of combinations for all the options, all 6 options. And finally, I'm taking the minimum cost at the last index, which is n by 2 minus 1, and all 6 combinations, and finally returning that answer. So this was the third problem. Pretty easy, I would say. Easier to implement and easier to get the idea. What main idea of the question is. Now moving to fourth problem. This is also pretty doable. In this case, instead of second, this just second part of second question. In this question, what we are asked was subsequence. Now, in fourth question, what we are asked is a subarray. Now, same, if we try to find a contribution of an element, what we need is number of possible subarrays. Now, to find number of possible subarrays, we can use monotonic stack. Now, why we are using monotonic stack? So we are basically finding next smaller, next greater element. Similarly, previous smaller and previous greater element, and based on it, we get a solution. That's main idea of it. I tried to solve it, but I was unable to solve during the contest. but I will try to solve it now. And I think my rank would be around 600 after 2 3 days. I'm pretty sure because this is. I'm pretty sure this is a AI generated solution. This also. How can someone write this many codes offline in 4 minutes after solving first three problems? Like in 2 minutes, 1.5 minute. He must be God or something. Third one, I'm pretty sure everyone wrote same similar solution. Yeah, this guy can be legit. Yes, which solution looks not AI generated at least. This is also not AI generated because this is its template. So I guess that's it for today. I will try to solve the fourth one and if possible make an editorial on it. And thank you for watching.